Copying and pasting infrastructure code across environments creates an unsustainable maintenance nightmare. These fragile structures eventually fracture and collapse under their own duplication. A Terraform module solves this by providing a single reusable blueprint. It is a collection of configuration files in one directory that eliminates the need to repeat code. This split screen shows the objective. On the left, 500 lines of duplicated code for a standard web server. On the right, a clean 15-line module block capable of spinning up independent development and production environments. To follow along, you need Terraform version 1.6 or higher, active AWS credentials, and a basic understanding of how to write resource blocks. Eliminating duplicated code establishes a strict single source of truth. This prevents configuration drift, the scenario where staging and production environments fall out of sync and develop unique, undocumented errors. We begin with the separation of concerns. This means isolating the reusable module blueprints from the code used to deploy live environments. In your workspace, create two distinct top-level directories. The modules/services/webserver-cluster directory holds our blueprints. The other, live, holds our active deployments. Inside the module folder, create 4 essential files: main.tf for resources, variables.tf for inputs, outputs.tf for data sharing, and a README for documentation. The variables.tf file serves as the module's API, or Application Programming Interface. It defines exactly how users are permitted to customize the infrastructure. Within this file, we define 4 variables: cluster name, instance type, which defaults to t2.micro, and the minimum and maximum size of the cluster. Defining variables as a strict API allows engineers to build and distribute scalable internal tools rather than static scripts. The outputs.tf file provides the mechanism to pass generated data, like IP addresses or server names, back to the user after the deployment is finished. Add an output block here to return the ALB DNS name. ALB stands for Application Load Balancer, and this output gives us the specific URL needed to access the web cluster. Now, migrate your existing web server resource blocks into the new main.tf file inside the module directory. Replace hard-coded strings like myCluster with dynamic variable references connected to the cluster name variable. Hard-coded names inside a module cause environments to collide. If 2 deployments use the same name, AWS rejects the second request, resulting in this error state. Parameterizing the instance type ensures the cluster size matches the environment's requirements, using small instances for testing and larger ones for production. This strict parameterization makes the module environment agnostic. It is now a safe blueprint that can be reused for any scenario without modification. With the module complete, we move to the live directory to begin the deployment. Create a main.tf file inside the specific path, live/dev/services/webserver-cluster. We use a module block to call our blueprint. The source argument uses this relative path to point from our live environment over to our modules folder. For the development environment, we assign specific inputs, a minimum size of 2 and an instance type of t2.micro. Repeat this process exactly within the live/production directory. This split screen shows the difference in scale. Development stays small, while production on the right is configured with 4 instances and a powerful t2.medium type. Run Terraform init inside the live directory. This command is required to pull the local module code into your active workspace. Skipping the initialization step after adding a module source is a common point of failure. Terraform must index the module before it can be used. Now execute Terraform apply to provision the infrastructure according to your development settings. Deploying 2 isolated environments from a single module proves the removal of code duplication. This structure minimizes configuration errors by ensuring every environment follows the same tested logic. The terminal confirms a successful apply. At the bottom, our ALB DNS name output is printed in green, providing the address for the live load balancer. Copy this DNS name into your browser. If the page loads, you have successfully proven the functionality of the modular deployment. We have achieved a modular architecture where development and production are isolated, correctly sized, and managed from a single source of truth. To wrap up, refactor your current code into this structure, complete the Day 8 blog post, and run Terraform destroy on the development environment to stop AWS charges. Mastering modules marks the shift toward engineering scalable infrastructure platforms instead of writing individual deployment scripts.